Hi everyone. So today we're going to work on our hypothesis test for the mean with a known standard deviation of population, but we're also going to introduce new way to get evidence to reject H sub O and accept H sub A or fail to reject. We're going to be using what is called the rejection region and critical values, and this is going to support the p-value compared to your alpha decision. So this is just another piece of evidence that we're going to use to make our decisions. Okay, so what exactly is a rejection region? It's a range of values in which the null hypothesis is not possible. So here's your section of your normal curve where the null hypothesis cannot exist. So this is going to help us make our decision. So if your test statistic falls in the rejection region, you're going to reject H sub O. If it doesn't, you're going to fail to reject. So the critical value separates the rejection region from the non-rejection region. So here's what we got. We have our test. Let's go with left tail just to show you. So here's our left tail test. Here's our rejection region. Okay, we're going to have a Z value. Let's call this Z sub C, Z critical value, or Z sub O. That's the way it's going to be, that we're going to get, and it's going to come from alpha. Okay? And basically, you're going to find it on your formula sheet. Okay? And we're going to create this section, and then we're going to put it together with our p-value. And we're either going to reject or fail to reject based on where your test statistic falls. Okay? All right, so we need our level of significance. We need to decide whether it's a left, right, or 2. We know that's based off of H sub A. And remember, your level of significance is your alpha. You're going to find the critical value for where the hypothesis test is. So you're going to find the z-score that corresponds to alpha for a left tail. You're going to find the z-score that corresponds with 1 minus alpha for a right tail. And for a 2 tail, you're going to divide alpha in half, and you're going to find both. Now, what I did is I put all of this on our formula sheet. So we don't have to waste time looking all that up. So I'll show you that in a second. And then you're going to want to sketch the curve. There it is. So here's your left tail, here's your right tail, and here's your 2 tail. So you're going to find this on your formula sheet on the back page where it says common levels of significance. So here's your alpha, 0.1. If it's a left tail, your Z is negative 1.28. If a right tail, it's positive 1.28. If it's a 2 tail, then you're going to put on a negative 1.645 and a positive 1.645. So I did that for each one of our most common levels of levels of significance, so we don't have to keep looking it up. It's right here on your formula sheet, as well as the test statistic formula, just in case. Okay. All right. So let's practice using our formula sheet to create these critical values. So we're going to draw our picture, find the critical value and rejection region for a left tail test with an alpha of 0.01. So we're going to draw our picture. Okay, left tail test. And alpha is 0.01. That means this area right here is 0.01. I'm going to go to my formula sheet. It is a left tail test. 0.01, negative 2.33. Negative 2.33. And that's all you're doing. Okay, let's try the next one. We're going to find a critical value for the region for a 2-tail test. Okay, so we're going to do a 2-tail test. Draw our picture. We're going to have a Z and a negative Z. Okay, basically we split alpha in half and that becomes 0.025. That's what's in each one of these because it's half of 0.05. So I'm going to go to my formula sheet, 0.05, 2 tail, plus or minus 1.96. So on the positive side, I'm going to put 1.96. On the negative side, I'm going to put negative 1.96. Okay, that's all we're doing to find our rejection regions. Okay. Now, how do we decide? So we're going to use the rejection region to conduct our hypothesis test. You're going to calculate your standardized test statistic. If it is in the rejection region, you're going to reject H sub O and accept H sub A. If it's not in your rejection region, we're going to fail to reject. Okay? So in other words, you're going to draw your picture and you're going to say, if it's in the shaded region, you're going to reject. If it's not, you're going to fail to reject in all three different pictures. So that's why it's really, really important to draw the picture in shade so that you can see the rejection region and see if you're going to reject or fail to reject. Okay, so let's do one and we'll see how it goes. So here's our steps. Okay, again, can we do the problem? So this is all about, can you do the problem? Okay, this H sub O, H sub A, and the claim. Okay, specify your level of significance. What is your alpha? Determine your critical values. And your rejection region. We're going to do this on our formula sheet. Okay, this is our picture. Draw your diagram. Probably have those two flopped. Okay, so remember this is our Z formula. Okay. All right, in or not in the rejection region. And then write your conclusion. Okay, so we're just adding another step. We're adding more evidence to back up our claims or back up our decisions. Okay, so let's do our example here. I have two for us to work on. Hopefully we'll have enough time to work on both of those. I think we will. So employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than one of its competitors, which is $88,200. Okay, so they're claiming it's less than. Random sample of 20 of the company's mechanical engineers has a mean salary of $85,900. We're going to assume the population standard deviation is 9,500 and that the population is normally distributed. At an alpha of 0.05, test the employee's claim. All right, so the first thing again, can we do the problem? Is it a random sample? Is the sample size bigger than 30, or is it normally distributed to start with? Well, we do have a random sample, but it's only 20, so it better say normally distributed, and it does. It's right here. So check, we can do the problem. So let's start with our HO and our HA. So again, we want to look in our problem and decide, what are we testing? We want to say, is it less than 88,200? So less than 88,200 puts it into H sub A. It makes H sub O greater than or equal to. Okay? And our claim is H sub A. Okay, so do we have enough evidence to support our claim? Okay, so what's our level of significance? 0.05. Okay. This is a left tail test. So we're going to draw our picture accordingly. Okay, so we're over here. Here's our rejection region. We're going to find our Z that corresponds to that. So our Z, okay, so this is 0.05. We need a Z that corresponds with the left at 0.05. So left, negative 1.645. Okay, so this is our rejection region. Okay, all right, so let's do our test statistic. And we have a sample of 85,900. Okay, so there's our test statistic, and round to 2 decimal places, I got negative 1.08. Okay, so now I'm going to come back up here. I'm going to change my colors so we can definitely see it. Is negative 1.08 to the left, because that's where our rejection region is, of negative 1.645? And the answer is no, because it would be over here. So according to this, based on rejection region, we're going to reject H sub O. Or fail to reject, I'm sorry. We're going to fail to reject. Okay? Now, because he's not in our rejection region, let's double check that with the p-value. Okay? So I'm going to look up negative 1.08 in my Z chart. Guess I'm going to have to go. Where's my Z chart? Yeah, get my Z chart. Okay, so negative 1.08. I get 1401. Compared to an alpha of 0.05, this is greater than. This also says fail to reject. Okay, so both are in agreement. Both are fail to reject H sub O. So right in our conclusion here. Okay. All right. And we're still going to use the p-value. There is not enough evidence, excuse me, to support the claim. Okay? All right, so we would be able to say a type 2 error. Can occur. want to say rejected. You failed to reject mean salaries are less than fail to accept, sorry. Not reject, accept. Or support. $88,200. But H sub A was actually true. Okay. All right, so see how both of them support each other. Now, if you ever are in conflict, that's a problem. Then something's wrong with your problem, all right? That there's either we did bad math or something along that lines that it's not. They should always be in agreement. Okay, there's another one here if you would like to try. I'll put that answer up again tomorrow because I don't like to take more than 20 minutes for our videos. Let me know if you have any questions, guys. I'll talk to you again real soon. Please stay safe out there, and I'll see you again later.